Great, you came back. Welcome to the part 2 of studying for your first semester final in AP Physics 1, Finding Patterns When Problem Solving. Remember, this tutorial could be very useful for a first physics class, and it can also be useful for AP Physics C. These are concepts, and physics concepts are physics concepts. Today we're going to talk about proportional thinking. You might not even call it that in your class, but I am sure you have had problems like this. It's really just a fancy term for you know what happens to x if you double v, or velocity. So I am sure you've had many problems like this, and if you haven't quite gotten the hang of it, this tutorial is the one for you. Now, there's a simple reason why students may not like these problems, and that is because that you are working with variables. A lot of times there's no numbers in here, and we're all used to plugging and chugging numbers into variables, but when it comes to just working with variables themselves, it gets a little more on the scary side. So, if you follow this procedure, you will do fine. Okay, now I'm going to take one of the more straightforward problems like this, and this is if you have studied gravitational force, or force between two masses. Now, if you have studied the force between two masses, then you will know that, and let's make this, we'll go black again. Come on, there we go. Okay. We'll go black again. Okay, so then this equation should be familiar to you. Now you're saying, oh yeah, I remember this now. Okay, so this is the force of gravity. This is the force of gravity, and that's a gravitational constant, and it's the force of gravity between two masses, and that is the distance between their centers. Okay, so right now, how would the force between two masses change if one of the masses was doubled? Okay, so this is the procedure that I like to do. Now, what I like to do is write the original equation, and then I'm going to put an O right below there. O can stand for old, or original, or initial, whatever you want. Okay, so that is the force that we're going to compare your answer to. Now I am going to write a new equation. Yes, I'm going to write a new equation. Internet not cooperating. Okay, so new, and I am going to, in the equation, account for the mass being doubled. So what were the changes? Well, the gravitational constant does not change. So one of the masses was doubled, so let's double the first mass. Wouldn't you just write 2 times m1? Sure you would. Did we do anything to the second mass? No, we did not. Did we do anything to the distance between them? No, we did not. Okay, now you probably agree that 2 times 3 is the same as 3 times 2, right? Okay, so it doesn't matter which way we are going to multiply these numbers, so I'm going to rewrite it. So I'm going to put the 2 out here. I like putting the coefficients out in front. And I'm going to write my G, M1, M2, all over R squared. Okay, now you might notice something. You might notice that this expression looks eerily similar to this expression. And so, what do you love to do in math? You love to substitute. So, I would say 2, and since G m1 m2 over r squared equals my original f, I'm going to substitute it in here. Oh, so look at this. My new force between m1 and m2 is double the old force. You did it. That's all it requires. You're just comparing the new to the old, and the new is equal to twice the old. And that makes sense because the bigger the mass, the more force there is between them. Okay, getting the hang of this? All right, let's try another one. I'm going to put this one up here. You could look at it later if you want. I'm going to raise this puppy up here. All right. Okay, so once again, you start with your equation. So what equation do we need? Let's see. How would the force between the two masses change if the distance between them was doubled? Okay, so I am going to write my relevant equation, same as last time. Okay, once again, this is going to be my F old or my F original, whatever I'm going to compare my new force to. All right, so now what things changed? Well, it appears, if I'm going to write my new force, put new here. Yeah, okay. New, my constant does not change. I did not change M1. I did not change M2. Oh, I did change R squared. So, it's double the distance. So it's 2R squared. I'm going to stop for a moment. Is that correct? Think about it. In this formula, I am squaring the whole radius, aren't I? In this expression, if I write it this way, am I squaring the whole radius? I am not. I am squaring the r and then multiplying it by 2. That is not what it means. So instead, I need to put the whole radius in parentheses. In which case, I'm going to get G, M1. Come on, internet. There we go. M1. Got a delay here. M2 over 4R squared. All right. Now take a look. I'm going to use another color of ink here. Here, can you see our original force in here? Yes, you can. And what happens? It is divided. It's divided by 4, isn't it? Or, so you could write, here is the old force divided by 4. So your new force is your old force divided by 4. It's 4 times weaker than your old force, which makes sense. You are putting more distance in between the two masses. So your new force should be less. So once you get your answer, think about it. Think about whether it makes sense or not. All right? That is basically the procedure. Okay? That's basically the procedure. Okay, now sometimes physics teachers like to get a little fancy. And so what they do is, instead of writing the problem in words like we did in the last slide, they draw pictures. So take a look here. This is the original problem, isn't it? You have two masses, mass 1, mass 2, and you have a distance d, or distance r, in between them. Now take a look here. What changes in the problem? Oh, one of the masses, you say, is doubled, huh? Let's use an arrow. What the heck? One of the masses is doubled, isn't it? Oh, that was just like the problem. Now you have to find the force. So here would be the original force. So that is just your F equals G M1 M2 over D. Okay, because R is equal, or D squared, sorry, R is equal to D. And now for this one, what would you do? You would have G, F equals G times M times 2M divided by D squared, just like we did in the other. And how about this one? We would have the force, the new force would equal G times M1 times M2 divided by 2D quantity squared. So this representation is the same as words. It actually might be even a little easier since they tell you already what to do with the variables. So don't be scared or whatever if you're given pictures. It's okay. It's okay. It all works. Okay, now here's a tougher one because they're not like blatantly asking the question, or you're not just blatantly, you don't know exactly what formula to use at first. That's the difference between this one and the last one, which makes it a little hard. So this is a kinematics problem. A car is going at a velocity v and it slides to a stop in a distance of d. If it was going twice as fast, how far would it take to stop? And just so we're clear, it was going at a velocity v, and suppose the driver puts on the brakes, and then the car stops. All right, so we got to worry about brakes here. So, what do we have here? I love drawing pictures. I'm sorry. I have to draw a picture. I'm just addicted. And I'm going to draw a car and a person driving, and the person has a big smile on their face. Why? Because they're in a physics tutorial, that is why. So they are going at initial velocity of v, and the driver puts on the brakes, and it screeches to a halt in a distance d. So here it is stopped. Okay, now I have basically three kinematic equations, don't I? I have my delta x equals v naught t plus 1/2 at squared. I have my v final equals my v initial plus at, and I have my vf squared equals v naught squared plus 2a delta x. All right, even though the writing looks a little cryptic, I am hoping that you studied enough where you recognize these formulas. Okay, so did the problem give us any time whatsoever? Really did not. So we're not going to be able to use that one. We're not going to be able to use that one. Oh, okay, that was simple enough. All right, so let's see. We're going to use this bottom equation, and it said if it was going twice as fast, how far would it take the car to stop? So we're comparing stopping distances. So what you would want to do here is you would want to simplify this perhaps, and then you would want to solve for delta x, or the distance. That's going to be our original distance. I say simplify it because, okay, I mean, I could just, just rearrange it with the variables, but before we do that, what's your final velocity here? I'll give you a moment and a hint. Yes, excellent. Your final velocity is 0. Okay, so your final velocity is 0. So, we can have, so we're going to have negative v naught, so I'm subtracting it from both sides, and then I am going to get to a delta x, and you're like, well, wait a minute, we're getting a negative, okay, well, your acceleration, if you think about it, is going to be a negative. It's going to be a negative. You know from the first tutorial, the velocity is going, come on, internet, there we go. The velocity is positive, and it's slowing down, correct? So your acceleration is going to be negative. So if you want, we could put that there. All right. In these problems, never let the negative stop you. All right. You're just looking really for the magnitude. So you cancel out our little negatives here. We will solve for delta x, and that is going to be v naught squared all over 2a. All right, and this is v naught squared original, or your old. All right, now I'm going to do a little tutorial magic. scrunch this down a little bit so I have more room, and I am going to rewrite my old statement a little bit bigger. So that's V naught squared all over 2a. Okay, and actually it's just v squared. All right, that was the initial velocity. It said in the problem, it said is going with a velocity v right before he hits the brake. All right, so now I want to find my new stopping distance. Okay, and actually, you know what? Let's even do this one better. It said that d, okay, is d. So let's do v naught squared all over 2a. And we could put d as, well, that's just d. All right, so now we have our new distance, okay, our new distance of stopping. And what do we know? We know that the speed was twice as fast. So it's twice as fast. Don't forget the parentheses. You are squaring the whole velocity all over 2a. All right, here we go. This is 4v squared over 2a. And what are you noticing? I'm going to pluck this guy out. That guy is equal to d. So my delta x new, the new stopping distance, equals 4 times d. If you're going twice as fast, you better be prepared to have a stopping distance of 4 times longer. So for all you new drivers out there, that's a big deal when winter is coming and there is ice on the ground. All right, just trying to watch out for your well-being here. All right, so really this problem is one of the harder ones you can get when thinking about proportional thinking. So if you did not understand anything in this video, or you need to review it again, or better yet, go do the problems by yourself and then start the video, or then, pause and continue the video. That would be even better, because when you work on the problems without looking at the answer, and you could do it getting the correct answer, you know that you know it. Okay, well, we've pretty much come to the end here. So just to reflect here, how to solve a problem with proportional thinking. You write down the equation that you're going to use. That's your original equation. You solve for the variable that changes, okay, meaning that if you want to know how x changes if you double y, then you write your equation so that you get x equals to whatever other variables are in the equation. Get them all to the other side. Label the x, or whatever variable is, with a x old, x original, x zero, x naught. This is the expression you're going to compare all others to. Now write your x equals equation again. Label your x as x new and put your changed variables into it. Meaning if instead of x, it's 2x, or I'm sorry, if it's instead of y, it's 2y. All right, so put all your changed variables in, rearrange your variables so you could identify your original expression. In those problems, I kind of circled the original variables, and see what number that this circled part is being multiplied by or divided by, and then interpret your answer. You can't go wrong if you use this procedure. All right, write your original expression first, compare it to your new variable expression. All right, hopefully you got something out of this tutorial. I highly encourage you to watch the part 3 in this series, and we're going to talk about what to do with graphs when you are given a physics problem. And always remember, hardworking scholars can do anything. See you next time.